Hello champions, welcome to our Form 2 mathematics lesson, and today we continue with the area part of a circle, and this is our lesson number 3. I'm your teacher Mr. Wanyoike from Hill Girl High School. Welcome. In our previous lesson, we were able to find the area of a segment, and we said there are 3 steps you need to follow when you're looking at the area of a segment. And for you to get the area of a segment, we said number 1, you find the area of the sector, and the sector is shown here below in this other diagram, which is QPR. And then you also find the area of the triangle, and then you subtract. For you to get the area of the segment, you subtract the area of the sector minus the area of the triangle. Now today we'll look at the area of intersecting circles. When you have two segments or two circles joined together, then you can get the segments of the two circles. Let us see how you look at the area of intersecting circles. And there are 2 scenarios that you need to consider. One is where the 2 intersecting circles are equal, and number 2 is where the 2 circles that are intersecting are of different radius. Maybe one is larger than the other one. But let us look at when they are equal, they have the same radius. For instance, we have circle A and circle B, and there's one in pink and the other one is in blue. So if they have the same radius and they are sharing a common region AB, the one that is shown there as AB, then we can be able to get the area of the shaded part, or the area that is shared by the 2 circles. Remember, the area of sector XOY is given by theta over 360 times pi r squared. Theta over 360 times pi r squared. And therefore, for us now to get the area of the segment, then we'll say the area of the sector, and then we get the area of the triangle. We subtract the 2, and that will give us the area of the sector of one of the circles. Now, for you to get the area of the shared region by the 2 circles, then you multiply this area by 2 if the 2 circles have the same radius. If they have different radius, then you have to look for the area of each of the circle segment separately. If it is circle A, get the area of the segment, circle B, get the area of the segment, and then you add the 2, and that will give you the total area that is shared by 2 circles. Remember this, that the area of the triangle, or depending on what you have, as we said in the previous lesson, you can use the formula a half AB sine theta. And in this case, A and B will be the radius, and that's why it is a half times R sine theta. That's when you use the formula a half AB sine theta. Or if you have the height of these triangles formed, then you can use a half AB times height. A half base times height. A half base times height. In this case, your base will be xy. The base will be xy. And the height then will be from the midpoint of the second point that we shall be calling either M or X. So it depends on what you have. Let us now look at an example. You're told that the figure below shows 2 circles with the centers A and B. The circles intersect at P and R. The length of AP is 8. That's the radius of the first circle, which is larger. And the radius of the other one, line BP, is 6 centimeters. You are given 2 angles. Angle PBR is 60 degrees, and angle PAR is 44.05 degrees. Then you are told to calculate the length of PR. And question number 2 is that you should find the area of the shaded part. Solution. Roman 1, or the first question, we are supposed to get the length of PR. And for us to get the length of PR, we need to know that this being the shape APBR is a kite, and we said that in a kite the longer diagonal bisects the shorter diagonal into a half, and therefore PR is divided into a half Therefore, Px is equal to xr, or the two diagonals are meeting at x, the one in red, and therefore the length of Px is a half of PR, because PR is divided into two equal parts by the other diagonal AB. So we say PXB, the triangle PXB, is a right angled triangle, and therefore that takes us back to trigonometry. And we have said that the longer diagonal is bisecting the shorter one, and therefore PBR angle, we also know that angle PBR is equal to twice PBX. In other words, if we know the angle at B, then the longer diagonal will bisect that angle in a kite. Remember, we have said the shape APBR is a kite. And therefore, we are saying that PBR, which is 60 degrees, is going to be divided into two, so that angle PBX is 30 degrees. Now, from SOHCAHTOA, we know if the angle at PBX is 30 degrees, then we say sine 30 will be equal to px, which is the opposite, over hypotenuse, which is 6. And that will give you 0.5, because the sine of 30 from your math table or from your calculator is 0.5. And therefore, when you evaluate when you work out for px, you find that px is equal to 3 centimeters. And remember, px is half of pr, therefore pr is 6 centimeters. So the length we need is 6 centimeters. Now in part B, we are required to get the area of the shaded part. And we say that to get the area of the shaded part, we need to separate the two circles, the one with the radius of 8, and the other one with the radius of 6. So we say, we start the one with the radius of 6. So we shall get the area of the sector minus the area of triangle PBR. Area of sector minus the area PBR. The area of the sector is 60 over 360 times 22 over 7 times 6 times 6 minus the area of the triangle PBR. So we use a half AB sine theta. That will be a half times 6 times 6 sine 60. And then we shall now add the other segment of the larger circle with the radius 8. So we do the same. We start the area of the sector, which is 44.05 degrees, which we were given the question, over 360 times 22 over 7 times 8 times 8. That's the area of the sector, minus the area of the triangle, which is a half AB sine theta. So it's a half times 8 times 8 sine 44.5. And when you evaluate that, you get the sector for the smaller one. For the sector for the smaller one is 18.86 minus the triangle 15.59. Then we add 24.61, which is the area of the sector of the larger circle, minus the triangle, which is 22.25, and the area of the shaded region becomes 5.63 centimeters squared. Let us look at example 2. You are told that the figure below shows two intersecting circles of radius 8 centimeters and 6 centimeters respectively. Again, here the radius are not the same. The common chord AB is 9 centimeters, and P and Q are the centers as shown below. You're told to calculate the size of angle APB and angle AQB, and then you're told to calculate the area of the shaded region. So in this case, we start with part A, where we need the angle APB. Now, to get APB, we need to know that AX, the length of AX is 4.5. Why? This is the shorter diagonal and it is bisected by the longer diagonal PQ into halves. And if AB is 9 centimeters, then AX, which is half of AB, is 4.5. Now we extract that triangle APX so that we have AX, which is the opposite of the angle at P, is 4.5, and then the hypotenuse is 8. So we say sine theta, in this case, the sine at P, sine theta is equal to 4.5, which is opposite of hypotenuse, which is 8, and you get that is giving us 0.5025. So we get sine inverse of this to get the theta, and when you do the inverse of sine inverse of 0.5625, you get that it is 34.23. Remember, this is angle APX, which is half of angle APB. So angle APB will be twice 34.23, which is equal to 68.46. 68.46 degrees. Now we need to get angle AQB, and we follow the same procedure. We know the length of AX is 4.5 and we have the hypotenuse as 6. So the half angle at Q will be equal to opposite, which is 4.5, over hypotenuse, which is 6, and that is giving us that sine, that angle, or we can say sine alpha, is 0.75. So we get the angle whose sine is 0.75 by getting sine inverse of 0.75, sine inverse 0.75, and you get that the angle at alpha is 48.59. So because this is half of angle AQB, in other words, AQB is equal to twice the angle you have found. So the angle AQB is twice 48.59, and therefore this angle is 97.18 degrees. 97.18 degrees. Now that we have the angles, we have the angle at P, that is angle APB, and angle AQB. We can now smoothly get the area of the shaded part by getting the area that is shared. That's the area between A and B, and then we can always get the shaded part. Remember, we have said that the quadrilateral formed by the point APBQ is actually a kite, and a kite is usually made of two triangles. So we need to get the area of these two triangles, or in other words, we need to get the area of this kite or the two triangles, and then subtract the shared region, the one that is inside the shaded quadrilateral. So the area of segment PAB, we need that area. In other words, the area of the segment of the circle center P, radius 8. And we said for us to do this, we need to get the area of the sector minus the area of the triangle. So in this case, it will be the angle is 68.46 over 360 times 22 over 7 times 8 times 8. That will give us the area of the sector minus the area of the triangle, which is a half AB sine theta. So it will be a half times 8 squared sine 68.46. And when you evaluate that, you get that the area of the segment is 8.48 centimeters squared. Now, we also do the same for the area of the segment of the smaller circle with the radius 6 and center Q. We know angle AQB we calculated as 97.18, so we say the area of sector here will be 97.18 over 360 times 22 over 7 times 6 times 6, or times 36, minus the area of the triangle, which is a half AB sine theta, or a half times 6 times 6 97.18, or a half times that 6 times 97.18. And when you evaluate that, you get that the area of segment here is 12.68 centimeters squared. Now, we look at the area of the quadrilateral APBQ. APBQ, which said is actually a kite made up of two triangles. The triangle PAB and the triangle AQB. Triangle APB and triangle AQB. So we can calculate this triangle separately and then sum them up to get the area of that kite. So we say the first triangle, which is APB, is a half times 8 sine 68.46, or a half times 64 sine 68.46, plus the other one now, which is a half times 6 sine 92.18, no, 97.18, and then when we evaluate this, you get that the first triangle is coming to 29.77 and the other triangle is coming to 17.86. So the shaded region, or the total of that, will be coming to 47.63. That's the area of the kite. So for us now to get the area of the unshaded region, then we need to get the area of the kite minus the area of the two segments. And when you do that, it's 47.63 minus 8.48 plus 12.68. Those are the areas of the segments. And that will give you the area of the shaded part as 26.47 centimeters squared. You can go through this, or once again, you can pause and replay until you follow how we have done it. And it's quite simple. It's a matter of separating the two circles. You do them separately, and then you put everything together so that you can be able to get the total area of the shaded region. Students, we have come to the end of our lesson today. I hope you've learned a lot. Keep replaying the examples and the lesson so that you understand the concept, and then you do the work that is here so that you're able to practice. And you can also do more questions from revision books, and this will be of great help to you. In case you have any question, you can always ask. On the last slide, we have the answers of the previous lesson. Mark and do corrections where you have questions. Always ask. Have a blessed day.
Feel the love he felt for us when he bore our sins. Listen to his words, let them come alive. If we know him as he is, there is peace in Christ. He gives us hope when hope is gone. He gives us strength when we can't go on. He gives us shelter in the storms of life. When there's no peace on earth, there is peace in Christ.